meetups. Thank you for coming. I know we're a few minutes late. We've had some technical difficulties. But we do actually have a jam-packed session today, so we actually have 5 speakers. First, we have Andrew talking about React performance profiling. Alex is talking about cognitive heuristics and software development. Ragan on his experience with mass transit. Stan on good dockerfile practices, and we'll be finished up with Michelle on why you shouldn't use microservices. So we'll start off with Andrew.
Hi everyone, my name's Andrew Farries. I work in the Foundry part of the product and Foundry division on the SQL Data Catalog product. I'm going to talk to you today about how you can use the React profiler to diagnose performance problems and how you can use component memorization to fix some kind of performance problems. So we're going to start by looking at a simple app that has a performance problem. Then we'll open it up in the profiler and see what's causing the problem, and then we will apply some memorization to fix it, and then we'll finish with some kind of conclusions. So if we first of all look at the example application, this is just a normal to-do list app. Like everyone who's ever learned React has probably written something like this. So you can add to-do items and you can check them off the list. But this one also has this button here, and if I click that, I end up with 20,000 items. Not only am I going to spend the rest of my life doing press-ups, but I now have a React application that has a performance problem because whenever I type in this box, it's really laggy and slow, and it takes a long time for key presses to show up. So if we want to see what's causing this problem, we can take a look in the React performance profiler. And if I start recording, just one key press, and then stop. So what you see here, this shows me which components in my application are re-rendering. So I've divided my application up into the form at the top. Well, there's an application component that contains the form at the top, and then this big to-do list I've extracted into a separate component called the to-do list. And you can see that when I pressed a key, the application rendered, but also that big whole to-do list rendered as well, which on the face of it is unnecessary because typing in the box doesn't affect the items in the list. So we don't want this to-do list component to render at all when I type in the box. So if we think about how we might try and fix this problem, so here's the application as it is. So we render the form at the top, that's the input box under 2 buttons, and then I render this to-do list component underneath. And the problem is I don't want this to-do list component to render on every key press. So the first thing I'm going to try to prevent it from rendering is to wrap the component with a call to React memo. So this gives you a memoized version of this component, and that means that it will only re-render if it receives new props, if its props have changed since the last time it rendered. So if the list of to-dos changes, or the on-item click handler, that's what controls the strike-through behavior. If either of those 2 props have changed, then it will re-render. If it's the same as the last time it rendered, then it won't re-render. So if I save that, so I can see that unfortunately this doesn't fix the performance problem. So typing in this box is still really slow. And the problem is that although we're passing the same set of to-dos into the components every time, the on-item click handler is actually being created afresh each time. So we're getting, although semantically it's the same function, referentially it's different. And it comes from this use to-dos hook here. And this is the toggle done. So we're creating a new arrow function on every render and passing that into the to-do list component. So I need some way of ensuring that this callback function is preserved across renders. So to do that, React provides a hook called useCallback. And if I wrap the callback function in that, and say that I never want it to be regenerated, I'll come back to that in a moment. So if I run this version, so now I've memorized the callback, so I should be providing the same set of to-dos and the same callback every time. Fix the performance problem, which tells me that the to-do list is not re-rendering on every key press. But I've introduced a weird bug, because now whenever I click on an item, it wipes the list. And that's because I said here that I never want this callback function to be regenerated, so I always get the same callback. But really, this callback depends on the to-dos array. So I need to specify what this callback depends on. Once I do that, I should get correct strike-through behavior and the fixed performance. So we can see, we have another look in the profiler. So you can see the application renders, but the memorized to-do list is grayed out, which shows that this child component of the application did not re-render on the keystroke, which was the behavior we were looking for. So the conclusions we can draw from this, the React Profiler is a really useful tool for checking which parts of your application are rendering in response to user input. It can be quite instructive just to open up a React application, do something and see which parts of the app are re-rendering. You'll probably find that you'll be surprised how much of your application re-renders. And a lot of those renders are going to be wasted in the sense that the component is going to produce just the same JSX output as it did the last time. Memoizing your components is the best approach to try and prevent these wasted renders. So that means that it will only re-render if it receives fresh props. If it renders with the same ones, it won't be redrawn. The caveat there, of course, is you have to commit to immutability of your props. If you're mutating props and passing them to components, passing them to memoized components, then your components won't update when you'd expect them to. We've seen that it's quite easy to ensure that the data you pass into a component is the same each time, but what normally breaks component memoization are callback functions because they tend to be created inline in hooks or render methods. And the way to fix that is to use the useCallback hook to memoize your callbacks so that you get referentially the same callback on each render. The caveat to that, as we saw, was you have to specify what your callback depends on. If you don't, for example, as we saw, if we never regenerate the callback, you end up with a callback that's closed over stale state, and that can lead to really surprising bugs in your application. It's not the only way we can fix performance problems in React. In fact, the simplest way to have fixed this one would have been simply to extract a component to house the form at the top. Then the state change would have been local to that component and wouldn't have caused the whole application to render. You can also sidestep the need to pass callbacks down the component tree by using a reducer and passing dispatch down via context as well, which kind of sidesteps this problem with memoization of callbacks. But as ever with any kind of optimization efforts, avoid premature optimization. So if you're the nice thing about React is that it's declarative and you specify your UI as a function of the state and you leave it up to React to work out what needs to be re-rendered. If you start micromanaging and interfering in that process unnecessarily, you're just wasting your time and sort of fighting against React as well. But yeah, the profile is really useful to figure out what components are rendering. That's all. Thank you.
Any questions for Andrew?
Yeah.
Just thinking about the fact that you were closing out something which you didn't declare as a reason that should regenerate the callback.
Yeah.
That feels like a static analysis thing that could be done.
It is. There's actually an ESLint plugin that you can install, and it will look at your hooks, because by convention all hooks are called use something, and it will tell you whenever you use callback if you've missed a dependency. So yeah, it is absolutely the kind of thing that a compiler could and should be doing for you.
Okay.
Thank you, Andrew. Okay, so again, thank you, Andrew. I've been enjoying your React series, and I think it's the end of the trilogy next time. Next up, we have Alex talking about cognitive heuristics and software development.
Hello, I'm Alex Kondratov from SQL Clone, aka iClone Bullshit, and I will talk about cognitive psychology. So, at one point of my life, I realized that when I write comments for the code, I focus primarily on the things that I have learned while working on this task. And that means that instead of answering the question what another person should know about the code that I wrote, I was answering the question what me from the past should know about it, which is a reasonable substitution. And it can be seen as an example of a heuristic, which is basically a quick and dirty algorithm that gives you a good enough answer in a fast way. So cognitive heuristics is a theory in psychology that views human thinking as based on different subconscious heuristics, which people constantly use to make judgments and decisions. It was pioneered by Daniel Kahneman and Amos Tversky. So the first example with comments can be seen as an example of anchoring and adjustment heuristic when to make it to assess some B, we instead take some known value as an anchor and then adjust it accordingly to get some representation of B. So in that case, I was taking my past self as an anchor for what comments should be written. Another heuristic is availability heuristic, which is basically if we often see reports of natural disasters on TV, then natural disasters must happen quite often. Represented in this heuristics is basically this person looks like a typical doctor, and that means that likely he or she is a doctor. Affect heuristic is the thing makes me feel good, so it must be a good thing. So one more example from software development is, for example, story points estimation. When we estimate in abstract story points, we can say it as an application of representativeness heuristic. First, when we say that, well, this task looks like a typical 5 story points item. And then we can do some adjustment, like, but it's a bit harder, so than a typical 5 story points item, so it's 8 story points. And this thinking may happen subconsciously, like as a subroutine, and we can have just a basic gut feeling that, well, that's a 8 story points item. So another example is that on some of my previous projects, I noticed that people do tend to have a more negative opinion of other teams when there are several teams working on the same project in different locations. So this we can try to explain it from the heuristics perspective. First, when something negative happens, like failed build or a defect, when we judge a person that did it, like ourselves, someone from our team, someone from another team, we usually factor in different external factors like code being hard to work with, multitasking, and so on. And it's harder to do this such adjustment with people from another team that works on another side, sits at another side of the world, because we don't know their environment that well and we cannot use it for adjustment. And another reason for that is that positive events from another team may be less visible because people see failed builds, but they ignore successful builds. And in your own team, you have a more well-rounded perspective about what happens. So how thinking in terms of cognitive heuristics can help us in this situation? First, just being aware of this distortion may help us to compensate for them. And also we can think of some practical measures to alleviate this problem, like we can have more person-to-person communication to make people understand the other people's environment better and make better adjustment when they judge them, and we can try making achievements of the other teams more visible to us. So in general, it's tempting to focus more on logical reasoning and build practices and processes around it, and see intuition or heuristics as something unnecessary, or maybe even as a liability, because it's imprecise, it's biased. But there's no way of going around heuristics, because we are using them as a base mechanism for retrieving our knowledge and experience and for base judgment. And it's better to see intuition as a valuable tool that we can harm to be better professionals and better human beings. So that's it. Thank you.
Does anyone have any questions for Alex? Okay. Thank you very much, Alex. Lots of interesting things that I'll need to go away and think about there. But next up, we do have Ragan, who's going to be talking about his experience with Mass Transit.
Hi everyone. Hi Ragan.
This is where we hope the technical difficulties don't return.
Yeah, all the user failings in this account. So, does anybody know what mass transit is?
Public transport.
Yeah, basically a truck. So I'm a huge fan of distributed architecture and stuff like that, and I've used Rabbit for quite a while. Is this working? That looks like my very bland and boring desktop. Excellent. My bus of choice at the minute, and has been for a while, is Rabbit MQ, and Mass Transit sits on top of it quite nicely. And it's an open source framework just for making applications easy. There we go. So yeah, open source framework for making distributed applications. And when I've worked with Rabbit before, it's always been quite a pain at times to serialise the objects, deserialise and move them about a bit. And this kind of just takes it all away with all the subscriptions and stuff like that as well. So I've got a quick demo. It won't take too long. There'll be lots of flashing screens I'm sure you'll be very happy about. But it came about as I wanted to pull out some of the capabilities that we have and just kind of play about with it and just see. So it's a good learning exercise for me. So my first capability that I was going to work on was a database registry API, and that's kind of what I wanted it to do. I would like to try and make that bigger without taking. Where is it? I don't know how to use it.
Next to share.
There you go. There we go. So I wanted this microservice. It's a stateless microservice, just an API that just triggered a message to kind of go on the bus and just say register this database. So looking at the code. The wiring up for mass transit is basically this, and that's all you've got to do. So you have a Rabbit MQ address, your username and password. You declare a bus, and you create it using the Rabbit MQ plugin that you can just download. And then to use it, you construct a message or command, in my case here, and you just send it to the endpoint. And what that looks like is, I'll get the pre-baked demo in. I should clear everything down first. That is a rabbit cooking true fatal attraction slowly. Okay, right, so this is my Rabbit MQ instance. I've got no exchanges here, apart from the default ones, and certainly no queues, it's all empty. If I fire up my database registry, a little difficult doing it on one screen, I'm spoiled. Looks like this, and then if I fire off a JSON payload with literally my server name, database credentials, please don't steal them. Shocking. And I fire that off. Then what happens in Rabbit is I just get one exchange created, and that's just because I've sent a command over. At the minute, nothing's subscribing to it, there's no queues. So to kind of make this come to life, I would want a subscription. So fire up a monitoring service, which is just a really basic NAF service that checks the information schema for all of the columns in the database. That then subscribes and creates a queue, and then kind of got some explicit bind then. So if we looked at the code on that for the monitoring service, for it to do that, simply is that's prepared. You don't want that. That's rubbish. This. So we declare the bus exactly the same as we did in the other microservice, but this time we're going to say that we want to receive an endpoint at the registrations, and then we're just going to consume it with a consumer. We can have any number of those in the given microservice, and the signature for that is it just consumes and you give it a context, and then you can do whatever you want to it. So this one is a persistence microservice. So if I kick off my registration again, we should hopefully see it comes up registered, and now it's notifying it. But that's all the wiring up done by mass transit. You give it a model, you tell it where to register, where to subscribe to, and then the actual code is very simple to kind of make stuff happen, which is what I like. But that dipping into distributed architecture, that then gives us lots of extensibility. So looking at the exchanges and queues, we've got one queue, a couple of exchanges. The monitor kicks out a heartbeat. Again, I liked ASCII art. Bit of a kick. Anyone like ASCII art here? Oh, you are in for a treat. So I've got a hospital going on, and that kind of gives me a nice little green traffic light. Yay! And if I kill my monitor, then what that effectively does stops the heartbeats going out to the queue, and these things turn amber and red and then spin up and keep things healthy. Really reinventing Kubernetes, but hey, whatever. So yeah, that's pretty much mass transit. Some key concepts there is you just declare a consumer and do all the work on the consumer, and then it's pretty straightforward. That's it. 5 minutes now. Massive thing. Any questions? Good.
Good. Thank you, Ragan. Probably some stuff that might be useful to people in core, but hopefully people in development might find it useful as well. But next up we have Stan talking about good dockerfile practices, presumably not what I'm doing.
Alright, let's see if this works. Perfect. Awesome. So, hello everybody, I'm Stan. I work in the White Sharks part of Foundry, and I'm going to be talking about the dockerfile practices. This talk was originally given by Tibor Vaz and Sebastian Vanstein at the DockerCon Barcelona last year. They both work for Docker, and I'll try to squeeze their 40-minute talk into 5 minutes. And here, how many of you are familiar with how Docker files work? If I can skip the first 20 minutes, it doesn't seem like I can. Never mind. Awesome. So let's start with some basics. What is a Dockerfile? A Dockerfile is essentially just a blueprint that just shows how to build a Docker image. It's just a set of instructions. And there is over 1 million Dockerfiles in GitHub at the moment, so they seem to be doing something right. There's a full Dockerfile reference on all the commands and how to use them on the internet. I'm going to go through that because that would take ages. So a few basic concepts. So image is just a template for running containers. It just references a list of layers, and a layer is just a list of changes to the root file system. So every layer is just going to specify how does it differ from the previous one. Docker also uses a copy and write file system, which essentially just ensures that only the files that changed need to be copied over. So if you have two applications running based on a single Docker image or two containers and applications, then it's going to take much less space as if you had two VMs running the same application, because that would just be double the size. And two other things that we need to look at is build cache and build context. So build cache is essential. Build cache just ensures that only the parts of the Docker file during the build run that change, so it doesn't rerun the things that don't have any changes. And build context are just all the files that the Docker file looks at. It's usually just a folder where the Docker file lives. Alright, so let's improve some stuff. So controversially, I have a Java application here, which has a Docker file, some documentation, some requirements, a README file, the code, and then in the target folder you have the compiled application that you can run. And the Docker file looks like this, so we're basing it on the Debian image, and we're just copying the application inside. We're then running apt-get update, installing some dependencies, and then obviously running the application itself. So there's the first obvious improvement that we can make here. So obviously we want to do that. But in all seriousness, this image currently is around 600 megabytes, and it takes around 1 minute to build. So the first serious thing we want to change is the order of caching matters. We want to make sure that we copy the application as far towards the end of the file as possible, because that means anytime we change the application, we don't have to rerun the apt-get update and apt-get install, because those are not affected by our changes in the code. By making this change, we are now making this Docker go down from 50 seconds to 1 second on every incremental build. So that's what it looks like now. After that, we don't actually need to copy everything, so the README and the documentation, all this stuff, if that stuff changes, we don't really care. We just, at this point, want to just copy the application that we're running there. So that now improves it from 1 second to 100 milliseconds. And after that, let's look at the actual installation of the dependencies. So before we did that, we were running the apt-get update and then also installing version dependencies. If we leave that way, what's going to happen is that if we add any dependencies in the future, only the build part for the install is going to be running because of the build caching that I was talking about, which means eventually you might get into the situation where the apt-get update never gets run, and you might end up with some out-of-date packages which might end up breaking your application. So if you can just kind of find units that you can put together and they have to run together at the same time, make sure you run them at the same time. And in reality, we shouldn't really be shipping any dependencies with us. So things like SSH, things like Vim, you don't really need things to run the application. Worst case scenario, you exec into the Docker container and install those, even though you shouldn't do that either, but that's for a different talk. All right, what's next? Surely there's well, actually, if we're really doing this, we might be just good citizens to actually clean up some cache and get rid of the things that we don't need, which is making the image smaller. But surely there's a better way of doing this ourselves. And there is. Use official images. We don't need to start at the Linux image and install everything ourselves. There is plenty of things over there which is already tested by different developers, so we should hopefully hope that it's okay. Docker Hub also has a vulnerability scan, so we also want to make sure that we use images that are approved and they don't contain anything that could harm us in any possible way. Probably the most important rule of this talk, use tags always, never use latest. What's latest today might not be latest tomorrow, and it will eventually end up breaking your application. I'm guilty of that myself. It did happen in the past. And when it comes to using specific tags, there's usually quite a wild choice. So here we're just using OpenJDK version 8, but in reality, we just need a Java runtime environment, and in reality, we can actually use just a minimal flavor of Linux because, well, we don't care about the fancy stuff in this kind of case scenario. And what happened is we just made our image go down from 600 megabytes to just 80 megabytes, which is really awesome because that's much, much smaller. So one thing we don't really have control over at this point is the application itself or the code. So what we're doing is we are copying in the compiled code and we're just trying to run it, and that means we can't really ensure consistency when we rerun things because whatever we pass in inside, it might not be same all the time. So actually what we want to do, and this applies also to our .NET projects, is as a part of the Dockerfile, we also probably want to build the project there and then just pass on the binaries onwards. So this is the Java way of doing it. We're changing the OpenJDK to Maven. We're just copying over some dependencies, and then we're just running build. Right, what's next? Just a small refactor. Try to use as the least amount of using past all over the place, because the more text you have in Dockerfile, the higher chance there is that you're going to make a mistake with some paths, and it's not fun. And then one of the last things, cache your dependencies. So this is an equivalent of running .NET Restore. So if you do this way instead of running just .NET build, the build is going to be faster because as long as you're not changing any dependencies, the build cache is going to cache it, and it means that you can just move on faster. And lastly, slightly more advanced, multi-stage builds. The reason we want to do this, so we want to probably use one stage where we build everything and then use the other stage where we just package the stuff that is runnable, because whoever is going to be consuming our package doesn't actually, our image doesn't actually care about how we're building the image, and there's no need to package all the build stuff alongside with that. That's it.
Thank you, Stan. Yeah, so plenty of stuff there that's useful if you're in Docker, and I actually think probably applicable even outside of Docker, so thank you. But last up, we do have Michelle talking about why you shouldn't be using microservices.
So, I went to an entire workshop at the NDC conference called Designing Microservices, and this is basically the very first bit of the workshop where Sam Unum takes everyone's preferences, what do you want to do, what do you want to cover, and then launches into this. Why you shouldn't use microservices. And the number one reason you shouldn't use microservices is if you're delivering to external customers, because external customers aren't yet ready. Possibly sometime in the future they will be, but currently when you try to deliver to your external customers, you them saying, what's a Docker? What is a Kubernetes? When you try to provide them with the 400 Docker containers that your software now is. The other one is if you don't have scalability issues. The whole point of microservices is to solve your scalability issues. If you don't have a scalability issue, why are you even looking at this? The slightly more surprising one, possibly, that he told us about was that you should be very careful about using microservices on greenfield projects. So completely new, this is the new thing that you're doing. And obviously that's a very tempting time to do microservices because it's a new thing. You don't have to disassemble an old monolith. But you don't know the domain yet. You don't know what you're doing. And if you don't know the domain, you won't pick good boundaries between your services and you will end up in a horrendous mess because it turns out it's really difficult to change the service boundaries once you've started. One of the reasons that people try to go into microservices at the wrong time is that what they want to do is they want to reduce work contention. They want to split up their software so that people can work on individual bits of it more easily. But you can do that without going the whole way into microservices. So I'm going to do another lightning talk in a while, which is the flip side of this, which is modular architecture, how to architect like you were going to do microservices, but without all of the overhead of the distributed system that you don't actually need if you don't have the scalability problems and so on that require it. Also, people try to do microservices because they want to ship quicker, and this all inevitably ends up with them shipping slower, because implementing distributed systems is not easy. And now you have an enormous problem where you need to spin up the whole system and test it, and that's now complicated. You need to think about all of these things that are just not a problem for you if you are not a distributed application. Another reason to avoid microservices is if you enjoyed data consistency, because you no longer have data consistency in the microservices world. There are a couple of ways of mitigating this, like sagas, but none of them guarantee atomicity. Atomicity is no longer a thing. You now need to go and recover from problems rather than just being able to use something with the acid properties that stops you having them in the first place. A test that he proposed for is your organisation ready to do microservices is, can you do log aggregation? It does all of the logging in the entire system that you're planning to do microservices in. Have you got a nice way of gathering that up and being able to see what's going on properly? If you haven't got that building block in place, you should not launch into doing microservices until you have got that together, because once you spin off into microservices, you absolutely need to be able to orchestrate and gather information from components and different teams, and if you don't have that, then you're not going to get anywhere with microservices. Okay, so why do people ever do this microservices thing? So microservices are great when you have an actual serious scalability problem, particularly when you need to scale up just one part of your application. You have a lot of stuff that you only need to do once, but just this one bit you could do with it running on 500 servers. If you don't have your thing in microservices, then it's very hard to isolate that one bit and scale up just the resources for that. Another reason for doing microservices is the problem where you have pretty much the opposite of the problem we have here at Ragan. You have one single system product, and you've got 200 developers who are all trying to work on the same thing, rather than at Ragan we have 200, we're more on the scale of having 200 products and trying to build them with 20 developers. And then the discipline of splitting it up into individual components means that you can have more developers working on the same thing, but you can get halfway there with modular architecture rather than actually requiring a services underlayer. Especially if you keep hiring new developers into this situation, and if you've got a microservices architecture, you can get them up to speed just on their thing. And also, most of the people who are doing this deploy to internal customers. So they have complete control of the deployment process. Either they can handhold each individual customer through it, or it's their deployments that they're working on. And they have access to the system so that when it does screw up, they can actually examine the running system rather than just having to rely on customer reports. And that's essential for current microservices implementations. So, with thanks to Sam from the delightful Any Microservices workshop event here in City London, and to opencliffart.org for all my terrible presentation needs. Thank you for listening.
Any questions for Michelle? Okay. Yeah, thank you very much. Looking forward to the talk on modular architecture. So, yeah, that's the end of today's lightning talk session. Thank you all for presenting. Thank you for listening, both here and on the stream. We do have some lightning talks news. Unfortunately, Andrea is stepping down as one of the organisers. She's done a great job over the last year or so. But we do have a new replacement. Jack is from Team Up will be joining to help organise. So you'll be talking to myself or Jack now. And the next sessions will be in 2 weeks on the 15th of March. And we are always looking for speakers. So if you want, please contact me for myself or Jack. Email, Slack, the Lightning Talk channels, probably, or privately, however you want to do it. And again, thank you very much, and hope to see you again in 2 weeks.